So what I want to do is I want to slowly, read about any kind of force, start moving towards the second theme of this class. That is, as I told in the beginning, I don't really take this whole software studies thing too seriously. Basically, they gave me money to start the lab, and I said, okay, I have to brand it somehow, so let me say something which I think is emergent. So anyway, but let's pretend I'm serious. And so as I told you, I can kind of think of software studies in two ways, which are mirror reflections of each other. In one way is we can actually start using various software as new tools for thinking and cultural analysis. Right? We're already using it to make art, communicate with each other, design. Might as well continue. And of course, there's a reverse perspective where we can start thinking about the whole phenomenon of software society and how society works. And I have a few things to say about the second perspective, but one thing which I want to talk about right now, because it kind of directly reflects to what we've been doing. So when you think about contemporary society, right, you think about public health and medicine and various sciences and governments of countries and municipalities of cities. I mean, all these multiple layers and points of control communication. Well, you can ask the question, are there some kind of common, almost universal ways of working with information which we will share, such as a spreadsheet? In other words, we can ask, are there some common, what I would call like epistemological technologies, right? Technologies for thinking, decision making, creating artificial memories, accessing these memories, recombining things, right? Technologies for mixing, decision making, and so on. Now, obviously, these technologies do not start with software, and they exist, I think, different levels of generality, right? From something as general as basic communication code, languages, images, arithmetic, mathematics, to instruments such as spreadsheets and notebooks. And I think you can basically say, okay, so what is the new thing which is brought in by the brought in by the software? Well, I mean, you can say that first of all, software allows us, right, to collect, manage, calculate massive amounts of data, and also in real time. And therefore, I think it enables new epistemological and techniques, and also techniques of control, which have to do with massive amounts of calculations. Right? So what's actually behind these calculations, of course, are various mathematical models and techniques. Right? So software itself doesn't really bring any fundamental techniques. It basically just makes possible for these mathematical models and mathematical techniques to be executed. Okay? In the same time, you can say that software perhaps does bring some techniques of its own, because the people are used to organizing information and working with information in particular formats, whether it is a spreadsheet or a vector graphics file or a MySQL relational database. Perhaps these formats themselves bring certain ideologies, epistemologies with them. So what we're going to do now is actually talk about what I would say like a very good example of this technique, which is directly related to what we've been doing so far, which is learning about contemporary techniques of information visualization and data analysis. And what's interesting about some of these techniques is that they're so omnipresent, right? They're so ubiquitous in contemporary society, management, industry, like all the science, that we don't have a name. Right? So perhaps if software studies is to actually do justice to its name, it can be almost like this discipline which would sort of describe the power of these techniques. Because I'm not sure who else is going to do it, because these techniques, right, based, right? They exist as software, as mathematical tools, and as ways of doing things. For example, constructing search engines or creating databases. And but it's not really about technology, right? It's about uses of technology to can govern, organize memory, collect information, make decisions. So what our academic disciplines would really talk about it, right? So these techniques really fall between. So might as well put it under software studies, but ultimately I don't care, right? So let me start by talking about one of these techniques, which is in some ways would be the next step we would do with database such as Mongo. And because we're in the process of actually doing it and kind of trying to figure out how to do it, I'm not going to actually present our very, I would say, rudimentary work in progress, but I will talk about the concept because the concept itself is much more general, right? And it's the same concept which is used in all the scientific fields, in finance, in a kind of let's say military. Well, I wouldn't say military, but various surveillance and anti-terrorist agencies, to calculate insurance rates, for marketing, for variable pricing. Right? So it's all based on the same basic idea. Okay? Well, so these techniques are very, very common. Okay. And I'm going to demonstrate it through 3 examples. Let's first ask a very simple question, right? How do search engines work? Such as Google search engine. So let's go. Let's go.
With a bit of introduction, maybe
yeah.
expect.
Right. But yeah. Well, I'm going to only focus on one thing, right? Okay. I'm going to focus on one thing. Actually, it's not history. So the basic idea. So let me first describe the basic idea of this, what I would call epistemological technology, and then I'm going to state a few examples. Okay. So what we basically been doing with Mongo so far is exactly the same idea, except in our case the end result or the end goal is different, but the method itself is the same. So what is the method? Okay. When you collect some data, the data can be results of experiments, and airline prices and airline routes and the time of the day, and it can be information about customers and credit cards and who default on loans. It doesn't matter, right? So then what you do is you have a number of, you can say data points, or we could say objects, right? Because they're not necessarily points. Typically a large number. But it can be just 100, it can be 100, it can be trillion, right? So Google, for example, we don't know how many pages it visits every day, but basically every day, a few times a day, it recalculates all the links between all the pages it finds on the web. And last year it reached a milestone where it says we're calculating 1 trillion links a few times a day. Okay. So it can be lots of data. Okay. So then, that's number 1. And step number 2 is you're going to kind of describe, right, each object by a number of features. So, for example, let's say we're going to go outside and put some. Let's say there's a project now in California to put like 1 million sensors all over California, so you can have accurate kind of model and, of weather and other environmental changes. Okay, well, so we can put a sensor outside. The sensor is going to collect, let's say, temperature, barometric pressure, and direction of wind and force. Okay, so you basically. Right, so each measurement is going to be like a data point. Let's say you collect it every once a minute, so you look at data point, and then data points will be described by these 4 variables, plus you're going to have a timestamp. So you basically now have like 5 dimensions, and since your data point is also located somewhere in space, you also have X and Y, right? So it's actually 7 dimensions, right? So the same idea would apply to anything else. Okay, so you have your data objects, and each object is described by a number of features. We can also say parameters, we can say variables, we can say dimension. So for example, in the case of manga, we have a title, and for every title we know the artist name, the author name, the country where it's originated, its intended audience, and also we can have anywhere between 1 and 7 tags, right? So we already have about 10 or 12 dimensions for each title. Plus, we also can measure brightness and architecture information, etc. So our big spreadsheet, which I think I was using earlier this morning, we have 1 million rows where each row corresponds to an object, where each column corresponds to some property of this object, which happens to be a page. So it's a spreadsheet of about 1 million rows and about 60 columns. And that's kind of small, right? It's small for size. Okay, so then the next thing, so sometimes these variables, you just measure them, you get them from some database, and sometimes you can calculate them, right? So for example, in the case of images, you're basically going to measure these images and calculate some of these properties. Okay? Now, and then what happens next? Well, all we did so far, we basically played a little bit of visualization, where we would make scatter plots, and take two of these dimensions and plot them at the same time. And I also used Mondrian this morning, and we took this little database which had information about art provenance, and we were looking at the scatter plot where each painting was represented as an XY coordinate, and because we're also able to represent other data as a bar chart, in fact we're able to navigate between about 4 or 5 dimensions. But this is basically like it's like toys, right? In the real world, you have much more. So what happens next is you have a variety of different technologies. There are dozens of them for basically finding patterns and doing other operations on this data. And this data and this representation itself, has 2 names. And even though you probably haven't heard about it, this is basically what contemporary world runs on. Okay, so if you go to Wikipedia, one concept which describes it is multivariable data. Right, so it's a data which doesn't just have 1 or 2 dimensions, but multiple dimensions. So statistics. Okay. And we're not going to get the formulas. I just want to understand the concept, right? Okay. Yeah, so the idea is that it's statistics. You don't necessarily have to use statistics to work with this, but the idea is that it's a data which has more than 1 variable. And then you have a bunch of different methods, right, which exist to work with data. Okay, and all these methods are what's used in banks, by neuroscientists, by geologists, by astronomers, by surveillance agencies. Right? So it's basically different techniques for working with data. Okay. Now, what kind of things do you want to do with it? Well, it depends. So let me show you kind of 3 examples of how the stuff works in real life. Okay. So our first example would be, that's one concept. And then another concept is, let's see if we can get this here, feature space. Yes, here we go, right? So the idea is that if you represent each object, right, by a series of properties, whoa! By a series of properties, you can imagine how each object is a point in a multidimensional space. Right? So each object has only 1 property. It's going to be 1-dimensional space, like a line. If it's a 2-dimensional space, you basically can get this x and y plot. But if your data has multiple dimensions, imagine it's an x and y plot, except it's not just x and y, it's x, y, z, etc., etc. So the idea is that you kind of, you don't really literally do it because you can't see it, but hypothetically speaking, what you do is you represent each object as a kind of point in this multidimensional space, which is called feature space. Right?
What is it called?
Feature space. Feature space, right? Because each feature, each property of object defines 1 dimension. So for example, in the case of environmental measurements, like 1 dimension would be temperature, right? The 2nd dimension would be, let's say, strength of wind. The 3rd dimension would be direction of wind. The 4th dimension would be x, location and time. And then each particular observation, right? Each particular object, kind of, right? Well, object observation captured by each sensor becomes simply a point in the space. Yeah, and then you can do different things with it. So the kind of things you want to do, you say, okay, I want to divide all these points into 2, 3, or other number of classes. That's one example. Another example would be you kind of want to calculate similarity between them. So let me give you kind of typical examples. So let's say you have some kind of system which tries to recognize if particular photograph or video contains a face or it doesn't contain a face. Right? So what you do is, in this case, again, every photograph would be like a point, right, in a number of dimensions, and you have to figure out, you have to kind of divide the space, right, in a particular way. So all the photographs which contain a face would be in one part of the space, and all photographs which don't would be in a different part of the space. But let me show you how it works, right, in practice. I mean, not really, but at least give you some examples. So, if you go to the Wikipedia page about PageRank, which is the essential part, but only one part of Google algorithm, you're going to get lots of maps, so we're not going to go there right now. It's actually not very complicated. Okay? But this is basically the description, right? So here it says we use more than 200 signals, so we call it also signals, but we can also call features, it's the same thing, to examine the entire link structure web and determine which pages are most important. Okay, so that's one thing we do. And then we also analyze all the text in the page, right? Fonts, subdivisions, precise location of every word. Okay? So without kind of going into more detail, the idea is that you go, you collect, right, as many pages on the web you can by web crawling. And then for every page, you record and you put in a database, right, all the information you can possibly measure. So for example, always you put URL on this page, you put all the text on this page, you actually measure, when you calculate a location of every single word, all the fonts which are used, and so on and so forth, right, location of images, every possible thing you can possibly describe and measure about this page, right, what Google puts in the database. And it also puts information about the links, right, which are pointing, which this page connects to. Okay? So the heart of Google search algorithm is a particular algorithm called PageRank, which is probably how you know that we borrowed the idea from already existing technique, which was used to measure the importance of different academic authors in different academic journals through citation analysis, right? Because in people published in Science, there's a very formal structure of citations, and you can simply do kind of network analysis and figure out which people publish together. And today there are various indexes, such as H-index, which in fact are used in sciences to measure the importance of a very particular researcher. And in fact, people are now talking about that, if we're going to start hiring sciences, we're not going to just take this person to dinner and see if he's nice. We're actually going to calculate his or her index. And then if people below a particular number, we're not going to hire them. So this is kind of coming to continue, but these measures existed for like 30 years. So Google basically took this idea and said, what if we can apply it to the web? Because the web, you can think about every web page as a publication. And what's happening?
It's just closing to the sleep. Standby very quickly.
Yes. Okay. So what Google does is basically examines, right, all the links between pages. This is this 1 trillion links it examines 3 times a day, and it figures out if lots of links, lots of our web pages, right, are pointing to a particular web page. This page must be important. Yeah, you can't do it. Yeah, wow,
1 hour?
Wow, because you actually power adapter here, right?
Yeah.
So.
But it's still in.
Oh, even battery. Okay, even battery.
Yeah,
Okay.
but if you can put it 1 hour, it's not.
No, it's okay. Okay. Oh, I can't do it. I think we have to.
Authenticate.
Sorry, it's like 1 minute. Okay. Thank you. Good. Okay, that's fine. So.
You're here. I think we should
Yes,
because we're not using this one.
well, we may use it later. Okay, I'm sure. Okay. So one of many dimensions, right? Every page it uses is all the links, right, which are connected to this page, and the links connected to pages which are connected to this page. But the point is that many people think that this is all Google is doing. Well, it actually uses like hundreds of our variables for every page. Now, I don't know exactly how many. In fact, I can actually show that to the guy who works at Yahoo, and he also couldn't quite understand. So here we say that we actually consider 500 million variables in 2 billion terms. Now, I don't think it means that for every page we record 500 million variables. So it's okay, but it's obviously a big number, right? So I actually don't know exactly what this means. I mean, to me, the person from Yahoo also thought that what basically the sentence is saying is that for every page we have 200 different descriptions, like 200 we call signals, but I call it variables or parameters, and we also analyze the text. Okay, and then, right, what we do is we use various algorithms, right, described here, right, the multivariable statistics. So we're not going to go into more details. We basically use machine learning, which is not even here, but we use a combination of things to basically figure out which in every possible category, right, which pages are most important. So every page gets a number between 1 and 10, which is its page rank. Right? It's page rank. So then what happens is that if you're searching, right, for particular terms, okay, searching for particular terms, first of all, it's going to find all the pages, right, which have these terms on the page. Right? And this is what you're going to get when you do a web search, right? So it says, okay, for these terms, I found like 1 million pages, but the most important thing is going to rank these pages, right? Because it wants you to show most relevant pages first. And the ranking of pages is what determined by this whole statistical analysis early on. Okay? So this is one way to use the idea of a feature space. In this case, use a feature space to rank every single object in importance. So I don't know if it's completely clear, if it's maybe 40% clear when I think I did my job, but it was told it will really explain to you. Right? But the basic idea is that what Google is doing, fundamentally, it's the same thing what everybody else in the world is doing, right? You take your data, you describe it with as much detail as you can, and then you basically apply various mathematical techniques to these descriptions to do different things. Right? So one thing you can do is, for example, you can say, okay, which of these points are more important? Another thing you can do is you can divide all these points into different classes. For example, here are the photographs which have faces, here photographs which don't have faces. And let me show you like another example. Actually, okay, so that's one. So another example was, another example was this one. Okay, so we're going to go to, so this is a service which actually was active in San Francisco a couple of years ago, and I think now we're expanding it and redesigning it. Okay, so the company is called Sense Networks. So what we do is, let me find out it. So this is actually basically shows you how it works. So the idea was that if you are in San Francisco, right, you get this free online application, and you can sign in or not, right? So it's completely optional. And if you sign in, you can simply receive the data, or you can also say, I'm going to broadcast my data, meaning I'm going to broadcast my location. So what the system does, I mean, I'm actually going to show a description, but let me summarize it first, right? So what we do is we continuously connect locations of all the users who basically signed up to the service. Let's say we have, I don't know, like a few 100,000 people. So it continuously records where these people are. And it also has another database, so let's say 500 hotspots in San Francisco, nightclubs, bars, restaurants, etc. And then what it's doing is basically doing a kind of similar thing, like Google, like everybody else, but the end result is different. So what we do is we also classify all people into a small number of classes, which we call tribes, where each tribe is defined by basically where people go at night. So what we do is, again, is another form of, you can say it's cluster analysis. So again, if you imagine a multi-dimensional space where, let's say, every point is represented, every person represented by a point, and there are multiple dimensions such as, for example, where this person was at any particular moment and what kind of place this person went to. And of course, the data is anonymized because what you want, you just want to get this data. You don't really care who this particular point represents to. And then what we do is we basically cluster it, right? We divide this into clusters based on similarity. And then the idea is that if you, when you use this application on your phone, it will give you this map, right, in real time. So also, if anybody is in San Francisco, you can try it. Which overlays the heat map over a map, which basically shows you like where things are happening, where people are, and of course you can also filter it by different type of places, right? But there are two interesting things there are two interesting things beyond that. So first of all, you see how it says in the corner, San Francisco currently is 22% plus busy. So basically what it does, it continuously compares the data at any given moment with all the data collected, and then it can tell you if tonight is a quiet night, a busy night, etc. The second thing what it does, because it basically clusters all the users by the kind of patterns of places we go to, right? It will tell you, well, the kind of places you like to go, this is what's happening tonight, and this is where people are, and of course it can also suggest new places. So there's a little video there which explains how it works, and of course you can watch it in your own time. Sense networks. Blah blah blah. Okay, so here what you going. Okay, so here's a description, which is probably says what I said much better. Okay. So here it is. Okay. So interesting thing is you don't have explicitly fill out any question. It simply finds these patterns through statistical analysis of the traces you leave as you navigate around the city. Okay. Now, so here is the little animation. I think this simply shows you, right, because I think simply taking a movement of people. And then there's another animation which actually shows you, well, in a kind of a schematic way, how our algorithm works. Okay. So basically, even though there are lots and lots of different techniques, right, which people use, ultimately, if you really want to deal with lots of data, everybody from Google to these people to everybody else uses at the end the same basic technique, but it's kind of a technique for machine learning. So this is maybe a little bit of illustration how it works here. Okay. Yeah. Okay, so what we can do is we can read this and I can basically translate it for you, right, into less technical language. Okay. So this is kind of obviously clear. Okay, so what you're going to see is stages in algorithm, right? First of all, identify 200 locations. Okay. Then, because you have right data from all people, create a network of how people move between these locations. Okay. And then each location is categorized, right? So you're going to see colored dots. Okay. So basically, each location is going to basically what we're going to do is something which is called cluster analysis. We're going to cluster, right, all the dots by similarity. Okay, but it's kind of complicated because you're not just measuring things like in one dimension, you're measuring things in multiple dimensions. Right? And then again we can group all the clusters based by your behavior. And finally we overlap it back onto the map. Right? And that's how it works, right? So I mean, again, I think the best way for you is just, if you're interested, look at this yourself and you just carefully, and you kind of get the idea, but I think the animation explains how you basically go from the spatial information, just the spatial information, to abstract space of these data points, and then data points are clustered, and you project this back into the space. So here is the network of movement. And now you kind of classify all the hotspots, right? We're going to get, okay, so you basically abstract this network of movements. So now we're just a network. And this, I guess, demonstrates symbolically, right, how algorithms can find, classify all locations by similarity. Right? And in this case, it's basically, it doesn't matter where those locations are, it's analysis, right, analyzing patterns. And then this is kind of projected back, right, onto the map. And again, without inputting any information about any particular place or person, well, we do put information about the place, we can kind of try to basically figure out the patterns, and then the system can do, I mean, my friend actually showed me the demo, it can say, okay, you like going to this place, so just to let you know tonight, the activity in this place is 2% higher than when I should be expected on a non-daily week, right? So everything is put in the context of trends and patterns. Finally, let me show you one more example, which is kind of more close to images. Yeah, so it's already been around for 2 years. And of course, this is like visible demos of this technology, but it's used continuously by millions of individual researchers, laboratories, states, governments, all kinds of agencies, and of course all the companies. Right? If you're doing oil exploration, you would use this to determine where to go and drill for oil. Finally, let me show you one more example. And this example is, again, it's a particular example from large category of the kind of search engines which allow you to search by visual similarity. So as you know, when you do image search on Google or Bing by Microsoft or other search engines, it doesn't really look inside images, right? It only looks at the labels, right? It only looks at the text around the images. Right? So it means, if you search for Apple, if you go search for Apple, right? Okay, so to search for Apple,